All right, so thank you for having me speak here. My name is Stefan Thomas. I'm CTO at Ripple. And what I do there most of the time is research. So we work on a bunch of open source technology. And I'm basically going to show you some of what we've been working on over the last couple of years today. So the main problem that we're trying to solve with this technology is the web is something that we all use. It's something that we all enjoy using, more or less. But there's really one big problem with it. And if you're following the news right now, you see this cropping up over and over. There's one part of the web that's broken, which is its business model. The web has no built-in way for somebody to actually make money directly from their customers, from their users, from their visitors. And so people have come up with these workarounds. If I go to a search engine and I want to receive some interesting search results, there's no way for me to pay half a cent for that search query. I have to actually find some other way to reward the search engine, and so people use advertising. Or if I want to listen to music, I can't just pay as I'm listening to a song. I have to have a subscription with the service, and I have to pay monthly in order to actually compensate them in a way that's reasonably efficient, and it's not a big hassle, and so on. So what's missing is this sort of way to, I get some value from the website. How do I reciprocate? And today, the way we do it is like we have this sort of side channel where the website, we work with an ad network, and then the ad network gives me something that has no value to me. It's actually kind of annoying. It makes my browser run slower. It maybe threatens my privacy. And it's just something that I don't really want, but it helps the website. It makes the website money. But of course, it's only a workaround, because I don't really want that, the ads. And so I install an ad blocker. More and more people are doing that, and then for a long time, for a while, people thought that what would solve that problem is mobile, because there were no ad blockers on mobile, but then Apple allowed it, and so now we're right back to sort of the same exponential curve that we were doing before, and more and more people are using ad blockers. And so even this workaround of advertising is actually starting to break down. So if I'm using an ad blocker, the website doesn't get any money. And now the websites, of course, they need to make some kind of revenue, and so they are starting to use ad blocker blockers. So you might go to salon.com, and it might tell you, hey, you're using an ad blocker, please turn it off. In the case of salon.com, it actually gives you another option, which is you can do cryptocurrency mining in your browser, not the most efficient way to monetize. But there's it's almost like a war has broken out between content creators and customers. And so it's not even a workaround, right? A workaround has to actually work to be a good workaround. So we just have a broken business model on the web. So let's go back to the initial state that I mentioned, which is, I'm getting this value from the website. What if we just add some way for me to reciprocate? What if we just add some way for me to give some value back to the website? And it's kind of similar to if you start any other kind of business, nobody asks you what your business model is, right? Like if you ever started a startup, people are like, what's your business model? Are you using advertising? Are you using subscriptions? If you start a restaurant, no one asks that, because you're probably going to just charge people for the meal after they're done eating. And so we think that it's just a symptom of that inefficiency that on the web you have to find these workarounds. So we want to come up with a better way than that. And the simplest possible solution would be, if I'm getting this value, what if I could just pay, just like I do at a convenience store, just like I do at a restaurant? If I'm getting this sort of little piece of value, a search result, a blog article, a little piece of music, a video, what if I could just reward the creators directly by paying at that point? And the reason that hasn't happened yet is because there is no payment method that is efficient enough. Whether it's credit cards or PayPal, if you try to send less than a cent, it's going to be too slow, it's going to be too expensive, and it's also going to be a proprietary platform, right? And you have a similar issue if you use something like a blockchain, where it's going to be too slow, it's going to be too expensive, and as somebody who's worked on blockchains for a long time, they are actually very difficult to evolve, because any change you make, you have to get a huge community to buy into the change. And so very simple things take a very long time. I was involved in one upgrade to Bitcoin in 2011 called Pay to Script Hash. And when we first thought about it, it seemed like something that we would be able to roll out very quickly, but actually it took something like 8 months to get it deployed on the network. And remember, that was when Bitcoin was a lot smaller than it is today. And the reason for that is because there's billions of dollars at stake, right? If we screw it up, if we do anything wrong, if people don't upgrade in the right time frame, people could lose money, and there could be real damage. And so you want to be very conservative. And so what we started to think about is, well, why isn't that a problem on the web? Why is the web something that evolves incredibly quickly, and why can't these large public blockchains evolve as quickly? And so what we realized was that what's different about the internet and the web is that they're both based on these very minimal protocols that actually don't specify a whole lot. They sort of just specify what you absolutely need to create end-to-end interoperability. So for example, every year there's a new Wi-Fi standard that comes out that's a little bit faster, but just because you haven't upgraded to the new Wi-Fi standard doesn't mean I can't talk to your computer, I can't have a video call with you. So the internet essentially creates this abstraction layer between all the different apps that need communication and all of the different methods for communication, whether it's Wi-Fi or satellite or fiber or any of these methods. So we started to think about, like, can you do the same thing for money? And initially you might say, like, no, money is a very different thing than data. It works very differently. But actually, when you just try to do it, sure you can, right? Like, all the internet does is it sends data on one network, and then it has a component that forwards it onto another one. And there's no reason you couldn't do that with money. You just send money on one network, and then you forward it on another one. So that's something that we started about 4 years ago, and it's called the Interledger project. It's now the third largest community project at the W3C out of about 300. And it's just behind, I think, WebAssembly and responsive web design. So there's quite a bit of interest in it. And it's a totally open protocol. We're trying to make it the most minimal spec that we can make it. And what I'm particularly proud of is that it has contributors from very different kind of backgrounds. So there's like developers, people are from the web community, there's banks, there's even central banks, payments companies. And so we're able to capture all of those different use cases within the community group in a way that, let's say, ISO with the ISO 20022 standards, which are primarily bank-focused, isn't able to do. Or EMVCo, which is primarily credit card-focused, or GSMA, which is primarily mobile money-focused. And really, like, when we started out, we wanted to achieve the same sort of outcome that the internet did, sort of, exponentially increasing performance and lowering of cost. But as we started to try to build it, we actually realized that a lot of the technical tools that the internet uses, as well as its philosophy of simplicity, are really good tools to actually achieve that outcome. So we started to copy more and more deeply from the internet to the point where now we actually have an architecture that looks very much like the internet architecture. So sometimes this is called the hourglass architecture, because you have the IP layer in the middle, and the IP itself is a very simple standard. It's just a data format for, you have a source address, you have a destination address, you have some attached data and some flags, and that's it. And then that can be sent over any kind of network standard, and you can send any kind of application. You can build any kind of application on top of that. And so that's what we're trying to do with Interledgers, which have like this very minimal format specified, where you can send money in this format over any network, and then you can build applications on top of Interledger instead of having to build them on one particular network. And I think that's actually one of the things that's holding the blockchain space back a lot, is that when you're building blockchain apps today, you're building them as an Ethereum app, or you're building them as a Bitcoin app, or a Tesla's app, or whatever it is. And so with an abstraction layer, what that means is that if somebody builds an app, it can run on any of these chains, right? And it can hold assets on any of these, and it can send them across. And that makes it so much more powerful, because then we're kind of acting as one community instead of these fragmented silos. Imagine if you were building your apps on Ethernet, and then somebody wants to use it on their Wi-Fi, and they have to re-implement their own app, right? That just wouldn't you don't get the kind of network effects that you get if you have an abstraction. So if you wanted to visualize what Interledger looks like, you could draw it something like this, where it's basically, just like the internet is based around routers, Interledger is based around a very similar concept of connectors. And what they do is they receive these, what we call Interledger packets, which are just packets of data. And they look at a routing table, just like a router would. And then they decide which peer they want to forward that packet to. They might do a few things that routers don't do, such as the packet that's coming in has an amount on it, and the link that I have where the packet is coming in might be denominated in a different currency than the link going out, and so I have to apply an exchange rate. But other than that, it is very similar to what an internet router would do. So that's where the connector is. There you go. All right. Now, we're sending just data around, so you might say, like, OK, well, how's there any movement of money? If we're just sending data, it's not really a payment network, it's just another internet, right? So the way that we actually introduce money is that at each link, we keep track of the packets that we've sent. So if we send, let's say, 1,000 packets of 10 units each, then we say, OK, now these connectors, this one connector on the left that sent all these packets owes the other connector some money. And it can pay that other connector through whatever means that they agreed on. And so they could pay each other through Bitcoin, or they could pay each other through Lightning Protocol, or through Ether, or whatever it is. They could even pay each other through cash if they want. And the main difference between what you choose is if it's a slower method like cash, if it's something more manual, more expensive, there's higher transaction costs, you would probably do it less often. And that means you have to have a little bit more trust. But if you use something like a digital asset, maybe one that has payment channels where you can settle literally, 1,000th of a cent and still have it be cost effective, you can settle all the time. You can settle after almost every packet. And so the trust required is basically negligible at that point. So from here, I want to show you a couple of practical things of Interledger actually running. And I'm excited about that because I've been giving Interledger presentations for a very long time, and for most of that time, there weren't very many practical demonstrations because it was still being built. But now we actually have some things to show. So the first thing I want to show off here is here's a little website. And think of this as like a video streaming website. And if I try to play this video right now, it's not going to work. And I'll explain why. So it plays for a second or so, and then it stops. And the reason is because this is one of those futuristic paid video streaming websites. So as you can tell, there's no ads anywhere. And so the way that this website makes money is by calling a new browser API we call the Web Monetization API. And the Web Monetization API tells the browser, hey, please send me a little bit of money for as long as you're on this page. Now, of course, Chrome doesn't support that yet. And so I have to actually enable an extension which is going to polyfill this API. And so now if I go back and the demo gods are with me, then hopefully this video will play a little bit longer. Nope, of course not. I will show you over here. So this is kind of a UI where you can see what's going on with the payment. And if it was working, it would basically sort of tick up every second. I might try one more time, but if I can't get it working, I'll move on. All right. Oh. It wants to. Oh, there we go. All right, second try. OK, now you can see the money counting up over here. And so you could kind of imagine, like, you're just browsing, and your money stream is just a resource, like your CPU or your memory or whatever you have. And so as you're paying, you're essentially purchasing more and more bits of the video. And if your stream has enough bandwidth, the video will be playing continuously. And of course, if I turn off the extension, the video will once again stop playing. All right. That part is easier to show because you just need it to break, so easy. OK, so now I want to show you some other stuff. So the way that this was working is actually through the Interledger LiveNet. So what I have here is a sort of graphical user interface that sits on top of a Interledger Tier 1 connector. So the Interledger network is very much like the internet. So there are Interledger service providers, if you will. They are essentially just connectors that are peered with each other. And so you can see if I go over here to the network graph, my connector has a couple of peers. My connector's name is 0, and it's peered with a connector called Scylla, and then it is peered with a connector called Africa, and so on. And then there are actually connectors that I'm not directly connected to, but I can reach them through one of the other connectors. And so this is essentially a view of my own personal routing table. And I can also show this in like a more technical way where the routing protocol that makes all of this work is very similar to BGP in that it's sort of people publish route updates to each other. When I get a route update, I might republish it, adding myself to the path. And eventually, the routes propagate through the network. And what that allows you to do, one thing that's unique about BGP is that it allows for policy-based routing. So for example, if I'm running a connector commercially, I might want to have some control over what routes I accept and what routes I don't accept. And I'll give you some examples about that. So there's something called the Gao-Rexford model, which is it's a model of how a connector would think about the cost of peering. And there are some connectors that you might peer with that have better connectivity than you. And so for those connectors, you would pay for the connectivity. So these are like bigger providers that are more closely connected to the network. And so you would pay for that connectivity because it gives you better, lower rates and faster transactions and so on. Then, of course, there are providers that are sort of the same size as you, and so they have similar connectivity. And so in that case, you don't have to pay. You just peer with them. And so neither side pays the other. And finally, you're a business. You have to make money somehow. And so you might have customers who pay you for connectivity into the network. And so that's kind of how it works on the internet. And in Interledger, we imagine it would be similar. And so one of the things that you might want is if you have two providers, you wouldn't want to route packets between your two providers because they're both charging you every time they send you traffic. And so you're paying twice, essentially, for every packet that you forward. And so you might say, like, my policy is not to route packets between my two providers. So those are the kinds of things that people have found in the internet, and we can essentially learn from all these experiences and apply them to this new context. OK, so now I want to show you some other stuff. So the first thing I'm going to do is the way I was connected to my Tier 1 connector is just through an SSH tunnel. So I'm going to turn that off. What that's going to do is it's going to free up all the ports that a ILP connector usually listens on. And then I'm going to run a local connector that is not at all connected to the Interledger. So now I have my own local network that is totally separate. And just think of it as I have a router that's just not plugged into the internet, right? So it can route packets locally, but it's not connected to anything upstream. And so if I go back to the status page, oh, you have to actually tell it to allow admin access. So we'll do that real quick. Here we go. So now, I just have my local connection. There's no routing anywhere. And I now have a different prefix called private, which basically means I'm on my own private network. I'm not on the public Interledger anymore. And it also says that up here, the GUI knows that we're in private mode. OK, cool. So now, let's see if we can build another app that is sort of payment-enabled and use Interledger to hopefully make some money. So I have an app over here. And basically, what it does is it has a couple of endpoints. It has a free content endpoint here. It has a content endpoint here. And what I want to do is I will keep the free content free. And so you can make those calls without any payment required. But then I want to make sure that anyone who's getting the normal content has web monetization enabled, and I'm getting some money out of them. So in order to do that, let's first run the version as we have it now. So I'm going to say, just run it. And now if I go visit that, we should see this premium photo gallery. And if I try to open a photo, it should load. But what I don't want to have happen is if I try to open a paid photo, it'll still load. But I don't have the extension enabled right now, so remember that. So we want to make sure that anyone who's looking at the premium content is actually paying. So in order to do that, all I have to do is I have to include this module called Koa Web Monetization. So that's just an open source module. If you're familiar with Node.js, you might know Koa, which is sort of a web framework. And this is just a module that hooks into that, but you could build a similar module for any other web framework in any other language. And there's sort of two places where we kind of hook it into our application. One is there's a client-side component to it, so we need to actually make sure that our client can load that. And then there's an internal endpoint to it, which is how it establishes a payment connection to my server. And I'm not going to go into too much detail how that works. We'll definitely keep iterating on this interface and make it easier, but this is sort of the infrastructure that we need. And now with that being in place, all I have to do is I have to add a piece of middleware that sits in front of my request handler that essentially charges the user. And that middleware is called monetization.paid. And then I have to give it a price. And I also have to say await balance, which means that you shouldn't start loading the content until the full price that I've given it has been received. And so that should be all I'd have to do. And so if I restart the application now, and I reload this page, and now I try to open the free pictures, it'll still work. But now if I try to open the paid picture, that should no longer work, and it just doesn't load. And of course, if I was a good web developer, I would then go and add some nice error message and things like that. But hey, well, it's time for that. So, so now I'll basically go and enable the extension. So remember that I have this local router, and both the extension and the application are connected to that local router, so they can talk to each other. So with the extension enabled now, I am actually able to pay for this content. So if I reload the page again, and I look at what's happening in this tab up here, you can see that once again, we see money streaming through. And of course, if I go over here to my local MoneyD instance, which is this my local router, you can see that there are packets indeed being sent through. So now if I try to open the paid picture, I can now see it. So just to recap, there's an open source implementation of Interledger called Interledger.js. This is sort of our reference implementation. It lives at the JavaScript Foundation, and it's the most complete implementation right now. There are Go, Rust, Python, and some other implementations in progress, Java, and .NET. So if you're interested, just go to interledger.org, and you should find links to all of these things. There's also, if you go to interledger.org, go to community, there's a chat, a Gitter chat that you can join where you can reach us and talk to us about this. So the API that a website calls in the browser, the way it looks right now is literally just window.monetize, and you give it an ILP SPSP receiver. SPSP is something that I didn't cover today. It's basically your HTTP equivalent. It deals with things like how to establish a connection with a certain receiver securely, and it kind of hooks into HTTPS to do that. But it's an application layer protocol, and if you remember that sort of hourglass picture, you could write your own application layer protocol. You're not bound to this. It's just something that, like HTTP. You don't want to always invent your own protocol. We showed you the minute extension. And then if you want to add a paid endpoint to your application, you can use something like Koa Web Monetization. And I would encourage you to kind of play around with this. A lot of this is still very early stage and pretty rough, but I'd love to see more people playing around with it and kind of giving us feedback and letting us know where they run into issues. Yeah, so that's pretty much it for the content portion. Now, before I so I'll kind of summarize. I think that ads are an annoying and potentially dangerous workaround. If you think of native advertising and journalism having to more and more compromise the separation between the editorial and the business side, I think there's some really dangerous trends there. So it would be a really good problem to solve. I think paying directly is a very good solution. I didn't really go into too much detail in terms of like what the user experience of that would be and so on. I think there's a lot left to be figured out, but that is, I think, a good starting point is to have the ability to just pay for the HTTP request you just made, pay for the API call you just made. Interledger actually makes that possible because Interledger is efficient enough to send money in such small increments. And so whereas this would have been not possible before, or at least it wouldn't have been possible in an open way, where previously you would have had to build it on a centralized platform, we can now do this. And finally, Interledger is out there, right? I think it's very early in terms of the network. As you could see, there weren't any connectors on there yet. But the technology is pretty stable now. It's pretty much ready. So very excited to see what people come up with and that they want to build with that. Now, I want to ask you for one quick favor. It's actually my nephew's 18th birthday today. And I couldn't be there because I'm obviously here. And so I wanted to take like 1 minute, and I would ask you to help me record a quick happy birthday for him. So I'll go and I'll say 3, 2, 1, and then we say happy birthday. Okay? All right, we'll do a test run first. So yeah, not that I don't trust you, but you know, I want to make sure there's anyone still awake. You can, with the lights, you can never tell. Okay, so 3, 2, 1. Happy birthday. All right, you got a passing grade there. All right, so Henning, ich wollte nur kurz Hallo sagen und alles Gute zum Geburtstag. Und ich glaube, da sind noch ein paar andere Leute, die auch noch alles Gute zum Geburtstag sagen wollen. Also 3, 2, 1. Happy Birthday! Thank you. Okay, so I think we have some time for questions.
Hey. Thanks again.
Thank you.
It's always good fun to get the audience to do work for you. Next time, do it in the first thing, then they wake up, and then they actually get the rest of the talk much easier as well. So we have a lot of questions, actually. So why do you think people actually want to pay real money for websites instead of what they already give Facebook and others, personal information, etc.?
Right. Well, so I think that the thing that people don't really think about or realize is that barter is very inefficient. It seems like we're getting all this content for free, but the time that we spend looking at ads has a non-zero cost associated with it. And so, you know, the cost that you'd have to pay to get rid of the ad, I think, would be on a level where it would be fine. The thing you have to think about is division of labor, right? So there's something that we're good at, that's probably what our day job is, and that's the most value that we can create in a certain unit of time. And so when we go to a restaurant, the way we pay isn't by doing the dishes for 3 hours, because that's a less useful way to spend our time than whatever our job is. We just pay. And so money essentially allows the division of labor. And on the web, that's just not the case, right? So rather than paying, which would be the most efficient, and you wouldn't have to spend time waiting for the, you know, Snapchat just introduced like a 6-second preload ad. So you wouldn't have to sit through that. You could just go straight to the content, and you know, theoretically, the economics should work out that makes sense for people.
Do you think it will take time for people to grasp that concept? It seems to me we have a whole generation of people thinking the internet is free because we look at some ads, and then we put an ad blocker in because we're clever, and then thinking that magical fairies throw the money at the people maintaining those websites. Now systems like Flatter tried to work around that issue for saying, like, you can donate money for every article that you read. Subscription models of newspapers try to do the same things, but all of them seem to kind of fail. Do you think there is a generational problem here, or?
Well, I think one big thing that was missing before is a technology like Interledger, because without it, you have to build a central platform. You know, Flatter collects everyone's money centrally in one place and then pays out the publishers and the content creators from there. And that has a lot of overhead associated with it, and it doesn't really scale to, you know, the global community and all the different use cases that you might want to have. And I'm actually, this is my last talk ever as Ripple CTO. I announced earlier this week that I'm stepping down to start my own company, and that is one of the things that we're really going to be looking at is, what does the user experience look like that takes advantage of this underlying open protocol, and then you can use it to, have some kind of flat rate the way you would have an internet flat rate that isn't necessarily like where your internet provider doesn't necessarily have a relationship with all the content creators, but rather you pay them and then they pay out per use or something like that, right? So that's something that we're working on. If you're interested in that at all, just go to twitter.com/coil. Right now it's coil_, and you can follow that. And yeah.
So the position of CEO at Ripple is free now. People can apply. What is planned to make it compliant with EU law? E.g., the user must be informed exactly what it costs before consuming it.
Yeah, that's a really great point. And that's actually one of the things why I think the flat rate model is so attractive. So if you imagine like Spotify, if you charged per song or something like that, people would kind of avoid using it any more than necessary, and potentially you would lose that engagement over time, and then eventually they'd stop using it altogether. Whereas if it's a flat rate, it's kind of like, well, I've already paid for it. I might as well have it playing all the time and then listen to it in the background, etc. And so the engagement gets really high. And if you think about it, that same thing has happened for the internet itself, where most internet service providers now use a flat rate model, because if I've already paid for the internet, I want to use it as much as possible, and I don't have to think about it. So I think the same thing can happen here. It's a bit weird to think about a all-you-can-pay flat rate, because it's not just that you don't have to pay for the fee of each payment. It's actually you don't have to pay for the payment at all. And so that's one of the products that we're very excited about building is sort of a all-you-can-pay flat rate where unless you are really being abusive the same way that if you were torrenting on your LTE connection, you might get throttled or kicked off. But if you're using it normally, we can even out the usage across the different users and just make sure that you have sort of an experience where you don't have to worry about overpaying because it is a flat rate from your perspective.
How do we deal with packet loss in between?
If you go back to this hourglass architecture, one of the layers between the application layer and the Interledger layer is the so-called transport layer. And that's where in TCP/IP you find the TCP bit. And what TCP does is it kind of resends packets, it handles failures, and so on. And so we do a very similar thing where we have a transport protocol which handles failures, it handles splitting larger payments into smaller chunks, it handles streaming data, it handles streaming money, and so you don't have to build that into every single application layer protocol. So there's essentially a protocol layer that deals with those sorts of things.
Okay. Somebody who obviously saw the last talk, how easy is it to add a new cryptocurrency to Interledger for us as developers?
So the way that it works is the connector has a plugin interface. We call it the Ledger plugin interface. And that plugin interface has sort of two main functions. One is send data, and the other is send money. Send money takes a single argument, which is a number. And so if you have some digital asset and you want to add it to Interledger, what you'd have to implement is that method, which is send money with an integer. And the way it knows where to send it is because each link is actually with a specific person. So I'm connecting to a specific connector over some cryptocurrency or some bank or whatever the case may be.
So it's just a configuration setting, more
exactly.
or less. Cool. What if I paid for one streamed video? Do I have to pay again, or can it cache save what I already played?
Yeah, so again, I think it's we started to rethink a little bit how payments work. Like normally you would think about it this way, where it's I've already paid for it, do I have to pay again? But again, remember we have a flat rate context, right? So you don't care about paying again. It's kind of like if you listen to the same song on Spotify again, sure, you're paying again, but it doesn't matter to you because you have a flat rate. You're not paying any more for listening to it again. And so this is something that might matter to the companies that are actually offering these flat rates. So they have to kind of think about what's the best way to pay the least amount, but then give users the most amount of value. And you can even think about like potentially specialization there, where we are making more of a consumer flat rate. Someone else might come along and make more of a enterprise flat rate, where maybe it doesn't pay for gaming content, it doesn't pay for entertainment, but it does pay for news articles and academic papers, right? And so there's definitely a fertile ground for innovation in terms of like how to solve some of these issues.
Mm-hmm. One of the poor guys said, doesn't it turn the web into a giant store like that? I would have to constantly check and compare prices instead of carefree surfing.
So the one thing I would always remember with new technology is that it's rarely taking something away. It's usually adding something, right? So the way I sometimes explain it is, right now what the internet is the sort of free cheese cube that you can get at the supermarket, right? Like, there are certain things where it makes sense to give you something for free, and there's a business model to pay for it, and that already exists, and that's great. And there's no reason for that to go away. Those business models are still going to work, ads are still going to make money, you can still have a website that's based on ads. All this is doing is it's adding another revenue stream that isn't indirect, that isn't going through an advertiser, but rather it's directly between the user and the website. And I think that that's potentially very powerful because there are a lot of channels on YouTube, for example, that are getting shut down, demonetized because their content is like objectionable to the advertisers. There is a lot of content that's now not as neutral anymore because there's native advertising and advertisers are influencing the editorial process. Those are all not great things. And so having some alternative way for a newspaper that wants to stay independent and doesn't want to be beholden to advertisers, a way for them to monetize, I think is really, really valuable to have. And I think it's an addition, not necessarily something that takes anything away.
Okay. One of the who watches the Watchmen kind of question, are the connector nodes operated by third-party companies like banks? Isn't breaking this structure the open distributed concept of blockchains?
I think it's closer to the internet, and like obviously Ripple works a lot with banks, and so we've been thinking about like who would run these connectors. And if you think about how it worked with the internet, especially in the early days, it wasn't the telecommunications companies necessarily that were first in line to become ISPs. It was new startups that were built around being an internet service provider, and then you would actually use dial-up to connect to them because the broadband infrastructure didn't exist yet. Digital infrastructure didn't exist yet. And so we would literally have a device that turns an internet packet into a series of noises so that we could have a phone call with a dial-up provider and connect to the internet that way. And so I think similarly, it's not going to be the banks that are going to be the early adopters of this. I think the banks have more of a role in that but lower layer where the settlement happens, right? So for example, Ripple, we do a lot of work on making very efficient settlement layers. And so by making the settlement cheaper, you just make everything above cheaper. And by introducing something like Interledger, you make the settlement part very competitive. And so that's good for a company like Ripple because we want people to have an actual incentive to switch to more efficient solutions because our solutions are more efficient, right? So introducing competition is good for us.
So who would be your Wishful first adopters? More like media companies, streaming companies, rather than banks?
I think it's very hard to say what the first vertical is. Like it could be music, it could be gaming, it could be news, it could be all of the above. It could be large sites, small sites, medium-sized sites. I think that's a lot of work that we still have to do is to figure out like what is our, for our company, what's our first target audience, and then for the community at large, like where can we attract early adopters. I think that probably the largest sites like Netflix and Spotify, they don't necessarily have the highest incentive to adopt this right away because they have a working business model. I think it's the second tier and down where the monetization gets more difficult, it's less efficient. It's much harder to get somebody to sign up for a subscription if you're not Netflix, if you're like the smaller provider, let's say. And then how do you provide enough value for somebody to actually pay monthly for your service? So I think those are more likely to be the early adopters. And then on the connector side, I think it's similar people as to the ones that ran early ISPs, right? It's people that want to find the technology interesting, maybe they want to create a business out of it and make some money.
Which ties into the next question. Do you think that people will pay for information on the web or will free sites win the battle? It's a bit like what newspapers try to do with subscriptions now, isn't it?
Right. Well, I think the way you should think about it is, as a user, I'm going to be making that decision of should I get an Interledger flat rate or not. And I can always choose no. And I think the experience I would get in that situation if I choose no is very similar to what I'm getting today, where I occasionally run into ads, I occasionally run into paywalls, I occasionally have to subscribe to services, and it's just like a slightly worse experience. And I think if you did opt into a flat rate like that, it would just enhance your browsing experience. It would give you more privacy, you wouldn't have as many tracking cookies, you wouldn't have as many ads. And I think like to some extent this is already happening with ad blocking, right? I can already turn off the ads, but this is more and more becoming sort of an arms race where the advertisers will then have an ad blocker, and so maybe my ad blocker doesn't work perfectly all the time. And so rather than continuing this arms race, why don't we bring content creators and users together because they have a shared interest. Like a lot of users want to reward content creators, and a lot of users want to be part of the solution. So I think it's very valuable to have the ability to do that.
Do you think a dedicated client or app or browser would be a good start with that? I mean, I see Beaker browser, for example, trying to disrupt the way we actually publish things on the web right now, where every user is also a publisher. Opera used to have a torrent client in it. Or would it be add-ons to browsers for starters?
Well, the first thing that comes to my mind is obviously Brave, right? So Brave is a new browser that's specifically going after micropayments. Right now they have more of a proprietary platform, right, where advertisers have to sign up with them, and they have a database that tracks how much to pay each advertiser. But you could certainly imagine them adopting something like this and using something like Interledger instead to have like an open way to pay the publishers. I think my personal latest theory is that we can probably build a pure JavaScript polyfill that content creators could use. This is something similar to what we did with web payments. So web payments is an API some colleagues and I worked on together with the browser vendors over the last couple of years. That's now actually rolling out to Google Chrome. It has deployed it, and Safari is now deploying it, and Internet Explorer is deploying it. And so when we originally made the polyfill for that, we did something very similar where you just had a piece of JavaScript, and then you would have wallet apps register with that piece of JavaScript, and then when a merchant wanted to request a payment, it would talk to that polyfill, and it would connect to the wallet. And so you could do something similar here, where you just have a piece of JavaScript, the browser has no support at all, but somebody has registered themselves as a web monetization provider, some website has registered itself as a web monetization provider, and then the websites that are actually trying to charge or take advantage of web monetization would call into that polyfill and be able to connect to that provider. So you can do it in pure JavaScript.
We're almost out of time. One last one here. How do you stop websites from charging too much money automatically? I guess the flat rate is the answer for that again, right? Yeah,
I think from the user's perspective, I want to have like total peace of mind. I can't have like a situation where, like what happened with early days of crypto sometimes, where like I have a bunch of money in my crypto wallet and poof, it's gone. So I think that by having a flat rate, it protects the user, and then it kind of shifts the problem to companies like ours, where we're providing a flat rate, and we don't want to get gamed, and we don't want to get exploited. And so we're up to that challenge, right? Like we want to tackle that and find ways to make smart payment decisions such that we don't run into those issues.
Excellent. Cool. Thank you very much. We now have a 15-minute break, so after that we're going to talk about Angular.